Thanks for watching my video. Today let us prove Lagrange theorem. Okay, and the statement is that let f be a function defined on closed interval ab such that number one, function f is continuous on closed interval ab and derivable on open interval ab. Then there exists some, let's say c belongs to open interval ab. These two are same. Okay, whether we write in first bracket or this third bracket but opposite. Okay, they are both the same, such that f prime of c is equal to f of b minus f of a over b minus a. Now let us prove. Let us define a function phi on closed interval ab as follows. Then is phi of x is equal to f of x plus a of x. Okay, where a is constant, where a is a constant to be chosen such that phi of a is equal to phi of b. Okay, now let us define a function phi on closed interval ab. Here closed interval ab as follows: phi of x is equal to function f of x and a of x, where a is a constant to be chosen such that where a is a constant, so that we should choose that phi of a is equal to phi of b. Okay, now from these two, phi of x is this one, and phi of a, in place of x if you put a, you will get what? F of a plus a of a equal to f of b plus a of b. Okay, now let us transfer here. A minus ab is equal to f of b minus f of a. So a common, minus a common, let's take b minus a is equal to f of b minus f of a. So if you find out a is equal to negative time f of b minus f of a over b minus a. Let's take this to be equation 1. Now since phi satisfy the following condition. Okay, number 1, our function, our new function phi of x should be satisfy the following. Okay, phi is continuous in closed interval ab. Since why phi is continuous? Because f of x is continuous already and a of x is also continuous function. Since f of x and a of x are both continuous in closed interval ab, implies f of x plus a of x is continuous. In closed interval ab. Okay, our new function phi here is a continuous because f of x is continuous by the statement, and a of x is also continuous. So sum of two continuous functions should be a continuous. Okay. Now number 2, or phi is derivable. Derivable in open interval a b, since f of x and a of x are both derivable in open interval a b, implies f of x plus a of x is derivable in open interval a b. Okay, now our function phi is derivable because our function f of x is derivable here already says. Okay, condition 2, and a of x is also derivable. Okay, because in its polynomial is always derivable. So sum of two derivable functions will be a derivable function. Okay, and that means what our Roman number 3 is phi of a is equal to phi of b, which is this one. Okay, this a is a constant, and a is a constant to be chosen. Okay, a is to be chosen, that phi of a is equal to phi of b, then is Roman number 3. So all these condition, what do you mean by this? Mean since phi is continuous derivable and this is equal to this, phi of a is equal to phi of b, that means Rolle's theorem is satisfied. Okay, since all the conditions of Rolle's theorem are satisfied. Okay, all the conditions of Rolle's theorem are satisfied, and there exists some value or some real number c which belongs to open interval a b. This is Rolle's theorem. Okay, such that f prime of c is equal to 0. Okay, this is our Rolle's theorem. Now in order to get f prime of c, now first of all this is what derivative, so we need to take this one derivative. Okay, this will be phi because our function is here, we take phi. Okay, so if you take the derivative of this one, okay, that means phi prime of x is equal to f prime of x plus a. Okay, that means differentiation of phi of x and f of x plus a of x is what? Differentiation of a of x is just a. Okay, now from here if you take, and we know that, okay, first of all phi prime of, if you place what? X by c. Okay, phi prime of c is equal to f prime of c plus a. So this implies that this is what? Here 0 already, so 0 equal to f prime of c is equal plus a. So which means if you find out a minus f prime of c equation 2. Okay, now from 1 and 2, from 1 and 2, what do we get? Both what? The right hand side are left hand side are equal, so right hand side should be equal. Minus f prime of c is equal to, what's that? Minus f of b minus f of a over b minus a. So minus minus, therefore f prime of c this is f prime of c is equal to f of b minus f of a over b minus a. So f prime of c is equal to f of b minus f of a over b minus a, which is our here proof. So this is our Lagrange theorem proof. Okay.